Okay, I think we are at the top of the hour.
Yes, it's right after lunchtime, so there is a bit of delay maybe, but we should start, I agree. So,
Okay,
do you want to put the timer or you want me to put it?
I've started it. We're already behind.
Yeah, let's see. Good. Please go ahead then. Welcome, everyone. This is the Sustain RG session. It's our first session after the chartering in January. And we are three chairs, myself here, Eve on the west coast of the US, and Michael in Oslo. So we're looking forward to chairing the Sustain RG. And as this is the first time we are meeting, we have a bit of a chair's presentation first. So we'll start with that, introducing the group and also what we want to do, how we want to do it. And for that, Eve will start and I'll continue. So Eve, over to you, please.
Okay. For those of you, I know it's the beginning of the week there, so I'd like to just remind you of several policies, things that you should note well. This session is being recorded, which means you're being recorded. And that means that implicitly by participating, you agree to appear in those recordings, audio and video. And unless you are wearing a red do not photograph lanyard, you will continue to be part of the recording. If you're participating remotely, that means if you turn on your mic and camera, you are agreeing to also participate. Just as importantly, any written correspondence in the chat and email lists also mean that you're part of the public record, and your personal information will be handled in accordance with the IETF privacy policies. I think one of the notes that we like to note very well is that we take heed of the code of conduct and the anti-harassment procedures of the IETF, and that we treat our fellow participants respectfully. So please note that very well. Additionally, there is an IPR or intellectual property rights disclosure set of rules, and the IRTF follows what the IETF puts forth. And that's basically advising that if you know of anything that is covered by a patent or a patent application that is either owned or controlled by you or your sponsor, that you should disclose that, and you should disclose it earlier rather than later. And you can see some of these RFCs that give the specifics and nuances of the copyright and patent policies. Also, if you want to look at any of these policies in further detail, this is where you might find them. At the very end, here's the policy, listing them all. I'm not sure if you get to see my pointer. Do you see my pointer on your screen over there?
No.
No? Okay, thanks. As a reminder, the goals of the IRTF are slightly different than the IETF. The IRTF is really focused on long-term research, and we are not looking at developing standards per se, although some of the research may graduate into standards. That is not our focus. And if you would like to read further about it, there's an IRTF primer for people who participate in the IETF. Also, again, since this is the beginning of the week, let me remind you that all individuals, whether you're in person or remote, should be using the Meet Echo tool. And you can see what those icons look like from the agenda slide, the full tool versus the on-site tool. And please make sure to use it, because that's how we're going to manage the queue. It automatically generates the blue sheets. And if you are not using the on-site version, but you are in person, please keep your audio and video off. The same holds for those who are remote. Please turn off your audio and video unless you are actually presenting. And we hope you will participate often. You can find pointers to those tools, the local and remote participation, as well as the meeting materials. As we've chatted into the public chat window, you can find the shared notes, and we welcome participation from all. And we also, something I should point out is that if you have something important that you've chatted into the chat window, but which you'd like to capture in the notes, please make sure that you copy it over into the notes section, although we will try to do so as well. And furthermore, if there's an ongoing interesting chat happening in the chat window, I would encourage those of you participating in that to get up at the mic and share it with the rest of us. So what are we doing here today? We have a full agenda. As Ali said, we will take a bit of time to level set this time, since this is our kickoff meeting, and share with you the motivation for the group, our vision, and extensively discuss what we mean in the charter. But then we are followed by several exciting talks. We have Yuka Manor talking not only about the importance of capturing the full life cycle, but also the ongoing debate about whether or not networks are energy proportional. That'll be followed by Yari and Suresh providing a snapshot or report out of an ongoing discussion around developing guidelines for network developers and architects on whether there are sustainable guidelines to be shared amongst this community. And finally, Dirk Kutcher will give us a glimpse of the much awaited, we'll get a snapshot. We don't get the final published report, but he's going to give us a glimpse of what happened at the Dagstuhl seminar, which took place about half a year ago, which focused on getting to a net zero internet. We've left quite a bit of time for open discussion, and we hope you will join us then, if not before. Although the agenda is quite full, we had several other topics that we had tried to also bring to you today, which we have queued up for future sessions. That includes some opinions about why we as the IETF, IRTF community really need to engage with the broader community working on the greenhouse gas protocol, or the guidelines that most of the other industrial sectors use. We'd like to share with you a snapshot of the state of the art of carbon-aware networking. Also, there is a very interesting set of materials that have been produced by the subsea networking community that was seeded by a grant from the Internet Society on how stakeholders across industry, academia, and government came together to analyze the sustainability issues. And finally, we are encouraging and have been beginning to work with individuals around hearing from those in industry about sustainability research as well. So why participate in the Sustain RG? Well, if you're like me, you feel some urgency about what we're hearing from the UN's Intergovernmental Panel on Climate Change, and that it's really important that we very quickly and very significantly try to reduce the greenhouse gas emissions that, when trapped in our atmosphere, contribute to the planet warming. And the timeline is pretty short for taking action, or the recommendations to take actions to try to keep the increase in temperature below 1.5 degrees Celsius. And as you may know, I ask all these questions to myself, like, well, what can I personally do about it? Well, as an expert in networking, as part of the information communications technology industry, we contribute to the greenhouse gas emissions, and our emissions have been sizable and growing. And even though data centers get all of the attention, networks have as big an impact or more than data centers, and that our impact is on par with developing nations. So if we as a community were a developed nation, we'd be in the top 20 countries. And you can also imagine, given what you read about and know about the growth in the use of data centers for AI and the networks in data centers and getting data across networks to feed and train models, you know that AI is exacerbating these problems, and that is leading to not only renewable scarcity, because a lot of the renewables are going to data centers, but it's also going to eventually, if these trends continue, impact electricity overall, not just the renewables. So quickly, I want to just share with you, with this backdrop, we came up with a vision for this research group, which is to contribute to the advancement of the internet as a fundamental part of a sustainable and resilient society and planet, and really focus on conceptual and evidence-based multidisciplinary research collaboration. We didn't come out with that out of thin air. We are also guided again back to the UN, which came up with this very thoughtful definition for sustainability, which is to meet the needs of the present without compromising the ability of future generations to meet their own needs. And they have developed about 17 different definitions or areas for sustainability, which can be categorized into environmental, social, and economic categories. And they are, again, you'll hear when I hand over the floor now to Ali, that those are important. All three of those are important, even though most of our focus will be on the environmental. So without further ado, I will hand over to Ali to speak to our charter.
Yep. Thanks very much, Eve. Again, from my side as well, welcome. And I'd like to thank Colin for being here to help chair the session locally as well, as this is my first time sitting here facing MeetEcho. As Eve said, basically we are a research community, and I would like to remind all of us a few things as we are setting the scene for this research group. I'll be brief, trying to leave more time to the presentations we have, and we'll go quickly. The scope of Sustain RG is indeed a long-term scope. It is a research group. It is, of course, longer term than the IETF working groups, but we are squarely focused on networking impact and perspective. It's not, let's say, long term. It is basically with a vision to create impact for the IETF and the networking community. And we want to focus on experimentation and evidence and data, because we see every day, even in our own deliberations, that there are controversy when people interpret data or evidence. And we really want to be, let's say, specific on what we are saying. And if we are singling out certain topics, architecture is one area which is very important, obviously, as well as policy implications. But when we say policy, it's a complement to what we are doing at IETF and IRTF, and not in terms of advocacy. And one key aspect is we are initially focusing on the footprint of the internet, and we are doing this while we appreciate the potential of the internet supporting the sustainability of other sectors, meaning the handprint of the internet. And we are encouraging a multidisciplinary perspective. If I also summarize our ambition, so we want to create a research community around our research focus areas. And I want to emphasize these words. We want to build a community because we want to achieve a common vision, a common goals, common methodology, but we also want to emphasize research, meaning we will mind diversity, we will encourage debate, we will go in depth, and we want to focus on evidence when we do that. So we hope it's going to be a lasting research community. And the first thing, the ambition we have, is to identify the research questions. We want to understand the questions, we want to debate the questions before we jump on the solutions A or B or C. So help us with identifying the questions as well. And scientific publications are the primary instrument we want to develop in this research group. And why do it in IETF and IRTF? Because we want to match the research community with the implementers in IETF. Basically, we want to bring the research academia, public research with the companies and the implementers wherever they are. This is a unique operation that we can achieve in the IETF. And as an early focus, so these are the first days of this research group, and we want to basically understand where we are. As a community, of course, who is around us, who else is working on this topic, but also internally, what has happened so far on sustainability in IETF and IRTF. And we want to focus on the research gaps, long-standing gaps we identify, which are controversial. As I said, interpretations are varying, and we are going to, let's say, look for champions. Essentially, we have to have people who own topics and who develop topics in this research group. No matter how exciting the topics, if no one is working on them, no one takes ownership, things don't move. So we have to be really practical, and we invite research colleagues to take up these topics. And on our part, we will create this community with indeed early feedback. You can come to the chairs, but also the mailing list to solicit feedback on your research questions, research directions. We will indeed try to match the research with the implementation potential there. And we also plan to give visibility through paper award or through ANRW. We'll talk about that in a second. And we want to sponsor also surveys on select topics, setting the baseline. And indeed, we will hopefully create a synergy with the working groups in IETF, notably with the Green Working Group, but also with others to chart the future of the research going forward. Now, I will go through fast our research areas. This is as indicated in the charter, so it's available, well documented. Characterization of the footprint is the primary topic we would like to, let's say, put on the table without characterizing, meaning understanding, defining, describing what the footprint of the internet is from an environmental, social, and economic perspective. It will be hard to mitigate that footprint. So we put this on the table as a priority. And we want to do this through quantitative and qualitative indicators and measurements and assessments, meaning that abstract assessments, opinions, or perspectives are not so much desirable as evidence-based, data-based, let's say, proofs of concepts. So we encourage this, and as we will see, a life cycle approach. Sometimes we are very narrowly focused, whereas in the sustainability impact domain, we have to be careful about the life cycle of what we are doing, from the production, implementation, operation, end of life. And this is particularly important, over which we have a presentation later on. And as you will see very soon, the greenhouse gas emission impact is the key factor. We see a lot of emphasis on energy, rightfully, but in the end, when it has to make an impact, this has to be in the emissions scope. And we are going to focus on that. And when we talk about emissions, it's the use phase plus the manufacturing phase, the embedded carbon. We are going to emphasize that as well. And materials and resource efficiency will be part of that. And as you will see with the presentation from Yari and Suresh, another key area is architecture, and what sort of internet architectures have what sort of impact on the internet footprint. Are different architecture options desirable? How do we compare them? What advice can we give to protocol designers? And another important topic, there is no shortage of important topics, but when we talk about characterization, when we talk about comparing options, we have to give a baseline figure, so where we are today, but we also have to give a target. Where should that parameter, where should that indicator be? Where do we want it to be to have a sustainable perspective? And that's very often missing. People talk about energy efficiency. They are talking about how well they are reducing the, let's say, energy consumption of a component, of a router, of a switch. Yes, but is that enough? Is that where it should be? Is that an overshoot? We have to have an idea, and that's what limits and boundaries mean. Where should we be for our impact to be acceptable from a sustainability point of view? Now, this has been the environmental side. There is the social and economic side as well, as Yves said. And without these three coordinating together, their impact is not going to be where it should be. We often see solutions, technology solutions that are good for the environmental perspective, let's say reducing energy consumption, let's say enforcement of renewables. Then if they don't make economic sense, they don't get adopted. Or if they cause a disruption in the social structure, that people don't have access to that specific technology solution, or there are barriers to entry in terms of education or awareness needed, these initiatives don't fly. And we are very cognizant of that, but we also acknowledge that our, let's say, know-how in the social and economic aspects of sustainability is not where it should be. We acknowledge this gap, but there are some limits to what we can achieve, but we are open to these perspectives as well. And continuing on from this angle, policy and regulation also play a role in sustainability in that they enforce some they could enforce some targets and limits and certain types of behavior in the absence of economic and, let's say, technical drivers. And we want to understand this in relation to our research. We are not going to go into advocacy or a policy, let's say, tool development, but we want to understand the complementarity of what we are doing with policy. Rebound effect is one area we all want to be aware of. That is namely what, if you read the literature on sustainability, efficiency is one tool and sufficiency is the other tool, meaning as much as you do things more efficiently, if they are overconsumed, then their efficiency gains are nullified. And we want to understand what room we have in impacting the rebound cycles. And if any, we would welcome the solutions. It's a hard problem. Climate change adaptation during the charter phase, we discussed this quite a lot. And indeed, this is an area where we want to discuss the adaptation of the internet to the already occurring climate change impacts, but it's a distinct domain, and we'll see if we have the champions on that topic. The mode of operation, I'll go quickly. It's basically through our sessions during the IETFs. We will do interims. We will engage with the community to do specific sessions. We will work internally and externally to build a network, basically connecting this research community with the research communities elsewhere. And one specific area which is coming up is the ANRW and the publications that we encourage. On the topic of RFCs, indeed, if and when we have something to share as a consolidated output from this research group, we'll do so. Now, I want to finish with a call for participations to the ANRW this year. The call for papers has been out, and I'm very happy to report that it includes sustainability-focused areas this year, and not only energy efficiency, but also the characterization of internet footprint, and the analysis of limits, and also all the topics that are within our focus. So I encourage everyone, the deadline is 15th of April. Now, we will have a discussion session at the end. I want to leave you with these questions. What would you like to bring to the Sustain RG? What do you expect from others in Sustain RG? And what's your favorite research topic that you want to work on and discuss and being handled? We have some time for questions. If now, please go ahead. If not, we can also do this at the end. So thanks very much for your attention. Okay, if no questions, we'll move to our next talk. Jukka will talk about first the life cycle perspective.
Maybe I'll try this. I hate these hand things. Okay, so I had two topics on the agenda today, and we'll take the question, comments, arguments, disagreements at the end of the second talk. So I'll run these two first, and then we can have the mic session. So starting with the life cycle. So a bit of a background. So I often see people kind of looking at the impact of ICT more from the energy consumption perspective, and sometimes emissions, some carbon discussions, and kind of the energy discussion is valid in a sense, at least in the short term. And I'll talk about how we need to kind of stop the current trend that we are seeing, and there's some numbers coming. But then in the long term, there's another topic which I believe is even more important in the long term, and I'll open that up in this presentation. So in general, what I'm advocating in this talk is really to look at the big picture and understanding the full kind of systemic impacts and the whole life cycle of ICT and whatever the IETF and IRTF are doing, so the whole ICT ecosystem as such. So if you start with the short term, then I mean, this is a picture that some people have seen, and a nice graphical presentation of one example where things might be going in the future. Now you can disagree on the numbers and whether this makes sense or not. This is not from Nature, the journal, but rather from was it Anders Andrei and his paper. There's been disagreements on whether these numbers are fact or fiction. We'll see that in a moment. But what I like about this one is that it on one hand shows kind of in general where we are heading. That if you look at 2010, maybe the biggest concern was consumer devices. But if you look at how the world has moved towards everybody here having portable devices, using mobile phones at home instead of PCs and big screens. So maybe the consumer side is not the major concern, but rather the networks and data centers. And I guess in Eve's talk, there was also mentioned that maybe the networks in the future might be as big of a concern as data centers, and data centers already are, I would say, major catastrophe, if you will. But I'll have some numbers coming. And for example, these numbers were, of course, one from roughly 2015, so way before the whole AI boom. So might be outdated in good or bad. But anyway, the high-level view in here, I think, is interesting. And there's also the production, which is the red line, which looks to be, at least in here, slightly growing, but is not necessarily the biggest part going forward. Now, the thing here is that you need to understand that all these predictions are about the world as one entity. But note that you have developing and developed countries. You have maybe a few data centers less in Africa, South America, parts of Asia, and then US, Europe. You have plenty of hardware, you have plenty of mobile networks, you have plenty of data centers and network equipment and so forth. So the world is not equal and even in that sense. So when we are talking about worldwide numbers, we need to understand that the impact in the so-called Western countries or developed countries is totally different than in other regions. So just as an example, for example, this is from 2 years ago. In Ireland, data centers overtake electricity use of all urban homes. 21% already 2 years ago in Ireland, data centers were using of the whole country's electrical energy. And that's only data centers. Then you add networks, you add end user devices and so forth. You get the slightly bigger number that even in the previous graph, there was this, that the previous graph was going to 20.9%. Then Ireland went past that already years ago. So if that's of any sign of what is happening in other countries, someone save us. So this is, for example, very recent from LBL report on United States data center energy usage. Very recent report. If you disagree the previous graph I show you, then this has the same exponential curve. And if you look at these estimates are in the 6.7 to 12%. Note this is data centers. You add same number for networks and consumer devices and so forth. So we are still looking at the same figures here. The way of Ireland, if you will. Here's, for example, from Netflix their government, their environmental social governance report, if you look at the absolute energy consumption, they are reporting 60% plus in 3 years. Think about any society where the whole society's energy consumption would be growing 60% in 3 years. It would be a national catastrophe for any nation. In the ICT sector, it's business as usual. Put this in perspective as a nation, US, in Thailand, 60% energy consumption growth in 3 years. I mean, where do you get that energy? Nowhere. One of my favorite is Google's report, very nice numbers. I mean, and again, if you look at this graph, this is not even linear, this is also exponential. This is Google's report on how green they are. The point is to show how much blue there is. But if you look at the growth curves, 200% in 5 years and 40% in the last couple of years, and this is growing all the time. So the trend is still, exponential. And this is just one provider, and all the big players are having the same ones. And I don't know what the AI will do, even increase the growth up to a certain point. Hopefully, there's a limit on that, but I fear I don't know what the limit will be. Maybe the availability of nuclear power plants seems to be the trend nowadays, that renewable energy is not enough anymore for these big players. It's nuclear power plants that you need to have. So again, the trends are not what you would like to. Now, one thing about these, big company kind of reports and how green they are, then they typically talk about renewable energy, that okay, we use renewable energy, so we are green, and end of story. Or about offsetting. Of course, this offsetting and buying whatever offset credits is one of the biggest scams in the world currently, and there's a lot of reports about that, but let's not go maybe there. But in terms of renewable energy, so we need to remember that there's no free lunch. There is no free energy. So here's, for example, United Nations Economic Commission for Europe. So analyzing the emissions per kilowatt hour using different energy sources. So I'll let you look at this graph for a moment. But if you try to find what is a green energy, the greenest energy, that's nuclear. So how much nuclear energy is being built worldwide? Very little. And that's based, at least in Europe, that would be the green way. Second is, smaller hydro, but even hydro is not being built, and no nuclear is being built. Germany even, dismantled their nuclear power. So if you want to talk about green energy, you talk about hydro and nuclear, at least in Europe. And I guess I would expect this is pretty much similar in elsewhere. If you look at, solar, wind, they have much higher emissions if you take the life cycle. I mean, these wind turbines, you need to build them, you need to install them, you need to service them, you need to, dismantle, recycle, and so forth. So there is no free energy. There are energy with different emissions. So this is a very good reminder of these discussions of, where you're using green energy. Well, there is no green energy unless you're talking about nuclear. Of course, wind, some forms of wind come close, but still a reminder. Then another point about wind energy. In Finland, there's a lot of new data centers coming, and they're saying that, yeah, we use renewable energy, and we're so green and so forth. This is from the Finnish energy, whatever association. This is from Fingrid, so the national electric grid. So what is the wind production in Finland? You have the maximum capacity, which the solid line, and then you have the production. There are days where there's no wind, there's no renewable energy. So if your data center is saying, or your networks or mobile networks say, hey, we use renewable energy, we use wind, so we're green, then what do you do on those days when there's no wind? If you look in the summer, there's less winds in the summer than in the winter time. So in summer, do you shut down your data center? There's many days when there's nothing, or there's 1,000 megawatts compared to the theoretical maximum of 7,000, give or take, and I guess now it's been rising to 8,000. So the change in the production, need to understand that. So, and with solar, you have the similar things. I mean, in Finland, solar doesn't really make sense, but people still do that. But wind, in some cases, makes sense. But if you think about ICT, that is definitely not, any ICT device is not built to scale with the available energy. This is from this year. So I just took just the most recent one. So again, if you look at this year, from January to, was it yesterday, then same phenomenon. You have days with zero wind energy. So if your data center, your ICT service is running on wind, then you fire up your diesel generators in this mid of February, and sometimes in June, and a few weeks ago, last week, you fired up your diesel generator, or what did you do to get your energy, because it's not coming from wind anyway. And if you look at the Finnish market as an example, because of course that's familiar to me, then all the new energy sources being built are wind. So the fluctuation again comes from zero to some big number, but it can also be zero. So in short term, the question is really that, of course, it's a wish, but could the ICT sector somehow be more flexible in the electricity usage? And somehow, is there a way to change the response to service based on actually available of real renewable energy? Of course, it doesn't make sense, but of course, if we're talking about long term, then just as an example, smartphones do that. When your battery is running out, it gives you a lower service, but it still works. And if you look at the growth curves, then they are just going up to roof, and there's no free energy, there's no green energy, there's energy with different emissions. So the kind of constant growth doesn't make sense. So then quickly to the long term, and then I'll switch to the second talk, which is slightly shorter. So if you think about these, Googles and all those, growth curves, where does the increase in energy consumption come from? Well, of course, it comes from new hardware. And the hardware probably has to be built. So for example, here's from UN, just a reminder of the e-waste and how much e-waste is going up. So stuff which is being built, whether it's refrigerators or routers, it goes all in the same category. And if you look at, e-waste documented formally, it's, 20% or whatever. And if I could have a 1 hour talk on the recycling and how much, where these materials come from and so forth, but recycling doesn't really work, and especially in ICT. If you think about your smartphones and laptops, you can recycle the outer shell, but that's about it. All the rare earth metals in there are almost unrecyclable. Just a bit more, give a few, maybe a concrete numbers. This is from one website. I mean, there's different reports on how much emissions comes from manufacturing smartphones. So here's some numbers from a bit older models, but still, up to 80 kilograms, from 60 something to 80 kilograms for manufacturing that phone. Of course, your laptops here and the routers and base stations and computers have different numbers. And this was actually an interesting reminder that if you look at the same phone model, you just increase the storage size, then your carbon emissions skyrocket. It doesn't change the size of the phone, just the integrated circuits, and your emissions skyrocket. Small but very significant. No change in physical size, but huge emissions. This is another document, and this one was also looking at different phones. They are pretty old ones, but there's also the point about the production, and then the light blue, which is the use phase. And now the use phase here depends on where you are using that. Are you using that in Asia? Are you using that in Scandinavian countries? So if you think about worldwide emissions from our world in data, there's a bit of a difference. There's light color countries like, Nordic countries, France, Brazil, something in Africa, and that's about it. Everything else is pretty dark. Some countries really dark. So the difference in emissions from the electricity is huge. I mean, 10, 20, even 100-fold, almost 100-fold difference in the emissions your routers use in different countries. But if you kind of try to be on the positive side and looking where the trend might be going, so this is the emissions from Finland, this is from the Finnish Energy Association. So this is what has happened in Finland. The average emissions from produced kilowatt hour of electricity dropped by 90% in 14 years. So if this isn't any sign of what hopefully will happen on this planet, then it will help a lot in the ICT sector, but it's still, there are emissions. But if you look at this drop, it's, unbelievable. Of course, Swedes and Norwegians will look at these numbers and say that these are huge compared to their hydropower, but, still on the global scale, this is, one of the best you can see on this planet. So just a quick calculations to end this first phase. So let's see if I take the smartphone as an example, and you think about the life cycle emissions. I'll leave out the recycling, which is another topic, and the logistics of shipping that from the manufacturing plant to the consumers. But if you use that phone, let's say if you take 80 kilograms of CO2 for manufacturing and use that for 4 years, your use phase emissions in Finland are 1.4% of the whole life cycle. And even EU average is 12%. So it's not the use phase, it's the manufacturing of those devices. And if their lifetime is short, then the emissions just grow and grow. So it's really the manufacturing which actually matters in the long run, and making building these devices. I did the same for a Dell server, which I found the data. It's a 2019 R740. Based on this Dell report, the manufacturing creates over 4 tons of CO2. You can look at the graph, the table on the right, and actually the SSD is the biggest problem by far. But if you include the SSD and you do the same calculation, the weighted average energy consumption based on that Dell report was 351. I had to manually calculate it, but I think I got it right. So again, we are talking about the life cycle emissions in Finland. 6% is the energy only. Even EU average is much closer to 50-50. I think in the Dell report it was closer to 50-50. Again, if you think about it, this server uses as much energy as driving your electric car 15,000 kilometers per year. Same amount of energy. So if driving around 15,000 is a lot, then every server like that uses that. And if you consider these AI things, then those are even higher. And just to maybe make a point, I mean, you have the same type of trend even in other sectors like cars. This is a Volvo report. And if you think about it, the same trend that, if you look at this report, emissions of your car are directly related to where you are driving that. So even if you are, driving, of course, the wind electricity based on Volvo's numbers doesn't create almost any emissions. But really the point is that if you look at the car's impact in the long run, it's about manufacturing. But okay, last slides to summarize, and then I'll switch to the next one. So, I mean, in the short term, we need to really look at the energy consumption and how do we drop the constant growth, but also understand that, energy isn't free. There is no green energy. There's energy with different emissions. But then in the long term, the devices just have to, in my opinion, last longer, be repairable, be upgradable, and not needing to be replaced every 4 years or whatever the data center life cycle is. So that's really maybe the summary for this first part, and then we have the second one
Coming up.
Yep. So okay, so then maybe a shorter one, but okay, they put me 15 minutes, but I guess I have 10 rather. Now it's going back. Yeah. So the background for this is that I've seen, for example, in the impact list and some other discussions, people's views that in networking you don't really need to care about load and send less data because there's no energy proportionality, so you don't really need to care about how much traffic you have in the network. Many people argue that any watt per gigabyte or stuff like that, metrics and KPIs are nonsense, as you shouldn't be using them. But maybe in this talk I'll try to motivate you why they actually make sense, at least in the biggest part of the networking on the internet. And we're talking about, I mean, just maybe to show the point that people are making, there's different numbers. The left one is from 2013, a Mircom report, and there's from Romain Jacob, some of his measurements on that are about, energy consumption with load, some Cisco catalyst on the lower right-hand side showing that whenever you increase load, it doesn't really impact energy consumption at all. I mean, there's in practice, no significant impact there, or pretty much none. In the next one, there was also, is it changing? Another one. I was trying to find router numbers, but I couldn't, but just for illustration purposes, again, a 9200 Catalyst series switch, and with energy efficient Ethernet, it's a bit lower, but when you add 10, 30, 50, 100% load, it doesn't really change anywhere. So, okay, I get that in this, network equipment, there is no energy proportionality. Whether it's a good thing or not, then that can be debated. I would say it's a bad thing. But I'm not a router manufacturer, so not gonna comment on whether it's technically possible or not. But cellular is different. And if you think about it, you all have your cell phones here. People are using them all the time. So it's, of course, the #1 and most popular access technology for people around the world. And it's the growing technology. Anyone who came here, you are maybe buying an eSIM, and all those talk about how much data you are using. So again, the cellular business, cellular network design and planning is about data volume and how much you try to carry. And when you have a certain data volume, and then you can also calculate your energy consumption, you can directly calculate energy and transmitted data in the network or even at the base station level. I have some numbers coming, so to make the point. Here's a graph. It's in Finnish, but the point that it talks about the electrical energy consumption of mobile data in Finland. You can see the years, which is probably an international. You can understand those, and GT means gigabytes. So left side, it talks about how many millions of gigabytes Finns were using in a given year. And then when you have the number of how much energy the mobile networks were used, you can calculate how many kilowatt hours per gigabyte. And the trend here is, of course, very positive. It goes down on the right side. So kilowatts per gigabyte is going down, but it's still, probably 10-fold or even higher compared to your fiber networks and so forth. So these are, of course, really big numbers. Then just for the fun of it, or maybe it's not fun, I multiplied the left side by the right side. So how many gigabytes Finns are consuming and how much energy per gigabyte. So 44% increase in 6 years. Same type of trend. This is more linear than the Google's, but still the more you have, even though you have energy efficiency, enhancements, you still have, issues with the growth of the usage. So this is directly related to the, how much data you need to carry, so how much hardware you need in your network and how many frequencies and radio modules and so forth. So of course we are talking about these things, just pictures from Helsinki 1 year ago. One thing to note in this picture, if you look at the base of each of these base stations, there's a cabinet. So it's not the antennas which are the big thing, it's the cabinet which is full of hardware. One of those cabinets can consume 10, 20 kilowatts. Every single one of them has a cabinet, and if you have 1 or 2 or 3 operators on the same one, you have a lot of hardware there, a lot. It's your mini data center, and every single base station is kind of, in terms of energy consumption, a mini data center. So in terms of saving energy in cellular networks, that's really, for cellular providers, it's, critical. I mean, GSMA said that, 20 to 40% in the OPEX are just energy bill. Of course, it depends on the country and the energy prices and so forth. 5G has been said to be so energy efficient that it will solve the problem, but at least currently you have 5G hardware along 4G. So you have actually invested in new hardware, but still you have the old ones running. Now there's a lot of different things that can be done in the cellular network, but at the end it's always a question of quality, if you will, service quality and energy saving. I have some examples coming, but it really is that, if you drop performance, you get lower energy consumption, but then it might affect your customers. So it's always a trade-off between service performance and energy consumption. So a couple of examples. So this continuous transmission. So this is not our measurement. This is from a rather old paper, but it makes the point that if you have different types of these continuous transmission features, and then on the x-axis you have bits per second per cell, and then you have the energy consumption, then those kind of go hand in hand if you have any forms of optimizations there. But that's an old paper, 2011. So of course the situation today is different, but our numbers also, I'll have some numbers coming, so they will have similar things. You can do MIMO muting, so multiple input, multiple output. You can shut down radios, you can drop your performance, you can save energy there, for example, as an example. So less transceivers, less receivers, so you can save on that. Of course, performance goes down, but for example, nighttime might make sense. Then of course, cell sleeping is a basic feature. So you have overlapping coverage with your cells, and you need to have that when you have a lot of load. But then at, for example, Bangkok, you have a lot of people, but maybe at night time you don't need that much capacity overlapping here and there. So there's a lot of things that can be done, but understanding that when you shut down a cell site fully, then it's going to take time before it comes up. We're not talking about milliseconds or even seconds in that case. This is just an example that what we are talking about. I took an example from downtown Helsinki, as took some base stations there and drawing their coverage area, and you can see that their coverages are overlapping heavily based on the expected traffic. And if you shut down some of those, you might save a lot of energy even without impacting customer experience, let's say at night time or in not so busy times of the day. You might do a lot, but this is what cellular coverage looks like. I mean, it's really overlapping with cells in here and there. So a couple of numbers, and then I'll stop. So this is one cell site. So this is real data from one mobile network in Finland. I asked one of my doctoral students to take one cell site and the numbers. This is not a very high performance. The lowest traffic is around 2 megabits per second, and then the highest is around 130 megabits, if I remember right. But you can see that there is a correlation, not a tremendously high, but there is still a correlation between the blue and green lines. It can be much more significant than this one. Here is one concrete example. So we have access to one Finnish operator, pretty much all base stations, all energy numbers, everything. So and very positive CTO who wants us to study that. So here's, for example, different radio modules and what is the performance and behavior. So this is comparing 4G and 5G. Now, if you look at, for example, 4G, so there's three sectors, the red line, you can see that there is a direct, almost linear correlation with the traffic and the energy consumption. With 5G, the base consumption is much higher, so at zero load, it's much higher, but then the growth curve is much better. We didn't have access, we didn't have any base station which were really highly loaded in 5G, so that's why the line stopped. But again, this is for one frequency, 3 radio modules. You maybe have three operators on the same base station, and each of them might have multiple radios, multiple frequencies running. So you can easily get to 10, 20, 30 kilowatts per base station site alone. So summary, maybe 1 minute late. So cellular networks do have energy proportionality, and they pretty much have to have that because energy is a major concern for the operators. There's cell sleeps and all sorts of technologies and features out there. And at the end, it's always a question of, quality versus, resource usage. That if you shut down features and shut down performance, then of course you lose in quality. But then it's a question of when it's worth it, when it's not. And then, but maybe my question is that can the fixed network do something like that? I mean, earlier I've heard that fixed networks don't do that, but could they follow the same principle? But that's it. Happy to take questions, comments, arguments.
Thanks very much, Jukka. Yes, please. The queue is open. Yeah, Jan, you're first.
Thank you. Lots of buttons to press before I can speak here. But, yeah, so we've been talking about this earlier, and just to reinforce the point that I think energy proportionality is an important thing, and it's an ideal. If you look back at the PCs in the early 80s, they didn't have any sort of energy proportionality at all. You turned on the PC, it was drawing the same current all the time. But 40 years later now, laptops have lots of technology in them to save energy in every way. So frequency control just being one of them. But so the router market is lagging behind, I'd say, by far compared to the wireless base station market. But do you know how large share of the network energy consumption that is going to the mobile networks as part of the whole energy consumption for all networks? And do you think that the economists at GHEP or SBTI and so on should assume that networks are energy proportional?
There was one, was it the paper from the Anders Andrei or some other researchers who I think did a comparison of fixed and wireless, and I think in one of those the wireless was like 6 times the energy consumption of the fixed network. So
yes, but as part of the whole energy, this is comparing one to the other. But how large is the share?
But if you then think about that in my previous talks, the kind of comparison between networks and data centers was roughly on par, and Eve in her slides mentioned that maybe data centers and networks are on par. Then we are talking about cellular networks potentially being at the level of data centers.
So should the GHP and SBTI people assume that networks are energy proportional?
Well, I mean, cellulars are fixed, no, but I mean, I don't have personal numbers to give you. It's it's all these, estimates are. There is, by the way, this joint, the EU GRC, the Joint Research Center report on EU network energy consumption, by the way. There is that. It was published last year. There is a report. They were trying to get numbers for network energy consumption in EU actually. So if you Google that report, there would be numbers for EU.
I think this is an interesting topic, but I will let next question, please.
Thanks, Jan. Dirk, you're next.
Thanks, Jukka. Very nice talks. On the first one, so what's your view on energy storage? You didn't mention that, I think. So batteries, for example.
Yeah, I mean, one of my colleagues at the university is a professor in energy systems. And let's say with current, lithium and stuff technologies, it doesn't make sense economically. So it's always a question of how much you need to invest, whether it's battery power, stuff like that. There are things people try, for example, in Finland, that in terms of using electricity to actually warm sand,
No.
to kind of do that. But I think currently, at least, well, I'm not a professor in energy systems, so I can't comment on how developed that is. But as far as I understand the energy storing, I mean, electricity is a fresh product. You have a few milliseconds or seconds to consume that. And you don't really have the storage currently. That technology isn't evolved yet.
Okay, I invite you to study the German energy transition program.
Okay.
Let's talk offline.
Okay, thanks.
Thank you. Angela.
My name is Huda. Just I'm using the tools of my friend. Okay, thank you so much for the great presentation. I want to add that energy consumption depends also on the used protocols, compression time, algorithms, not only ICT hardwares.
Sorry, so it depends on.
Can you approach the mic? We don't hear you well.
Okay, so I want to add that energy consumption depends also on the used protocols, routing algorithms, coding time, for example, not only depending on ICT hardwares.
Yeah, right.
It's not.
Well, it's so but you're talking more about the signaling and management plane.
Yes, because you mentioned that it depends in hardwares and products. That I want to add that it depends also on software.
Yeah, it is. Yeah.
Thanks, Huda. Jari, please.
Yeah, thank you, Jukka. Just one sort of small comment here. Your last slide sort of implies that it's always, trade-off between energy and quality, and we sort of have to trade off something in order to make any improvements. I just wanted to disagree slightly with that statement. There are also things that actually just make sense and are an overall win. One good example in the cellular networks is that there's a lot of this maintenance or system information, other kinds of messages that you have to be broadcasting all the time on all channels and on all base stations, and you can actually make them less frequent and send them only on some channels and so on, and actually has significant impact on the base stations energy consumption. So that's one example where we can actually do better without sacrificing anything.
Yeah, I should probably use often an optimization question, not always. True.
Thanks very much, Jukka, for the presentations. Much appreciated. We're moving now to our next talk, which is coming from Jari and Suresh. Jari presenting Sustainable Network Architecture. You have the clicker.
All right, thanks. We've done some work this winter and spring in the team that's on the screen to talk about what architecture could do for environmental sustainability. And we have an initial draft out, and I'll talk through some of the things that we have covered in the draft. So first of all, like this sustainability topic is obviously super wide. but we actually wanted to narrow down our work on a very particular problem of, are there guidelines that can be helpful for protocol designers and network architects? So sort of zooming out of all the other questions like, where does the energy come from? What does the application do? And, what are we using the internet for? And many other questions are outside the scope. And so the question is, how can we provide actionable design advice to network and protocol designers? Or in some cases, you'll see in a bit, but, we've been able to not provide actionable design advice, but we have some questions that, if we do this research, perhaps in this research group, then we could get to that actionable advice in a larger number of cases. Anyway, so that's the scope. And you might ask, what is architecture for us? So it could be a number of different things. It could be architecture diagrams to achieve a particular function. So as an example, the Green Working Group is working on frameworks to collect energy consumption metrics. And for that you need, this is the design, you need these kinds of nodes and so on. We're not really trying to do that in this exercise. That's ongoing elsewhere in other working groups. You need to be aware of some of the fundamentals, of course. You have situations like you have this multi-objective optimization that you want to have, in Jukka's words, like, both quality and energy savings, so sort of a multi-objective optimization situation. You might have trade-offs between different factors like resilience and various costs and so on. So you need to be aware of those things, but we sort of taken them as given. Then you might have these design patterns that was what we were a little bit more after, if we can find them. Can we have these patterns that could help build sustainable protocols and network designs? For instance, what could you do or what do you need to do in order to have scalable networks that match the demand that you might have at the moment? So some examples of these design patterns, it's about scaling, measurement, transport protocols, lifetime of networks, and encoding. I'll cover this in a bit more detail. Starting with measurement. So of course, understanding where you are is the basis for any improvements, and that, there's lots of past work and ongoing work at the IETF and the Green Working Group again. That's great, and there'll be progress there. And as already stated, you'll need some architecture even to collect measurements. But we also wanted to highlight a few different kinds of considerations that one needs to have when thinking about this. So one thing is that it's not just about collecting and, for the sake of collecting. You actually have to think about the cost versus benefit. You might have situations, for instance, where you have dark data that you aren't using at all, that doesn't make any sense. Or you might have situations where you're collecting data and make decisions that don't justify the cost of the collection. So you need to think about that. And also you need to build systems that generalize beyond the first metric. Typically, you're very interested in power consumption, but as you can note, there's other things that also matter and will matter more in the future. So whenever we design something, we should make sure that generalizes to be able to carry also, like, I don't know, carbon information and maybe even some of this manufacturing time information. And if you have any metric definition or data models for metrics or pipelines for processing things and collecting things, that they should also be sufficiently general. We also should not expect that all data is in the latest and greatest format, standardized last week at the IETF. There'll be legacy systems that you'll need to support, so build for that. We might not have all data available, so we in the team talked a lot about modeling, that you have to, you have some data that you can actually rely on, but then you have some missing things and you have to sort of still consider it somehow, but you can build, in some cases at least, some mathematical models that you can model the missing things. So build for that. And of course, no data is useful unless you actually know where it came from and what's been done with it and so on. So you need some metadata to go with everything that you might be collecting. The second item is scaling, and this is sort of the context is that you need to have ability to support time varying traffic demand. And you also need to support various kinds of requirements for resiliency and reliability. And of course, you need to be sustainable at the same time. So this is one example of those multi-objective optimization problems. And so some of the basic tools that you need for this, and as Jukka talked about, the power proportionality is really a key here. Of course, that's probably not sufficient by itself. Unfortunately, it's often not sufficient by itself. We can't get in, depending on what the link layers are and what the technology is and what the chips can do and so on, there'll be things that you can't make entirely power proportional at all times, or at least not to the extent that you want. So you'll end up having to power off some things at some times, sort of more a crude mechanism. So those are the basics. But then what do you actually do? We thought that this is sort of, it's a bigger problem than just thinking about an individual device that, now I turn it on and now I turn it off and so on. You have to think about the system, what the system effects are. And I'll illustrate this with a diagram a little bit similar, but simpler than Jukka's diagrams or photos. So this is sort of a overlapping cell cellular network diagram where there's one macro cell and then several smaller cells for capacity. And the idea here is that you can power off some of the microcells during low demand periods. But how do you actually go about doing that? First off, you need some information. So this information might be about your current offered traffic demand, or it might be also past statistics that during night it's typically like this, and therefore we make a more fixed schedule of what things are on at different times. But you need some information, so that's sort of the first assumption, that you need to have some flow of information coming to the system in order to make something out of it, make the right decisions. And then secondly, you need to manage the impact on the rest of the network. What we don't want is that you turn off willy-nilly some devices, and then the rest of the devices are going like, well, I can't reach that guy anymore. Like, what's happened? My router isn't responding. So we don't want that. We want something that's managed. In the mobile networks, it's sort of relatively easy because it's a highly managed, controlled environment where everything's signaled that now you have an opportunity to send, 3 milliseconds from now on this channel, and so on. So it could be relatively simple arrangement from the point of the phones, at least, that you get information when you can send and when you cannot send, and you don't even necessarily know that the thing that you're talking to the antenna is now powered, recently powered on, or the previous antenna that you were using is now powered off. You don't necessarily need to know that. In other contexts, it's of course different. Like in compute, you may have to move workloads. In routing, one example is the TVR work, where you pre-configure the fact that at 5 p.m. you shut down this link, and then nobody's confused at 5 p.m. what happened. Everybody is aware of that. And of course, you still need to engineer the residual impacts that you have a particular network diagram, and it's not that you shut down things willy-nilly and don't really understand what the impact on latency, for instance, but you actually have to design that. The third thing is transport. And what could transport do? Maybe multiple things, but the one that we focused here was ability to cause sleep to be possible for some of the devices involved. So some work has happened on this earlier. Michael Welsel has had a paper on that. If you send faster, it may be an overall win if the devices have energy proportional. So instead of downloading a video all the time as you're watching it, you download chunks of it and then go back to sleep for a bit and so on. But of course, there's multiple factors. You can't, for instance, cause congestion, obviously. And even if you don't cause congestion, you might still disturb other traffic by causing queues to build up. And there's some other work on that aspect. But it might be possible to have all of these things considered together, and for instance, to send as fast as possible while monitoring the queue sizes and making sure that you're not disturbing others. Equipment lifetimes are also important, as Jukka was talking about. And here, of course, you need to make some smart decisions as a network owner, like when it makes sense to upgrade and when not, and have to actually calculate. But also at design time, you need to think about whether you optimize for the current use or possible later reuse and extensibility. And you might reuse your core router on the edge and so on. And of course, you also have trade-offs between various kinds of extensions or upgrades, whether you do software or hardware. And it's better to do things in software, but on the other hand, sometimes you actually need the hardware updates in order to be able to improve the fundamental power efficiencies. And the last thing that I'll talk about is encodings, which is, of course, if you encode messages in shorter number of bits, then that's great. We have had some examples of that in the e-impact workshop a couple of years ago. Maybe the main question that's remaining here is, where would that actually be useful so that it would actually have a real world measurable impact at the level of the internet, and or would it have an impact? Are there protocols or fields in protocols that would actually matter in this sense? So of course trade-offs also there. There's some recent work on compression mechanisms that are based on AI, where you obviously have a compute power versus data transmission power trade-off. Yeah, so that's basically we had a few recommendations in the draft. One of them is that we have to look at the impact of these things. We only should do things that actually have a significant impact. Scaling aspects is one of those things. More detailed guidance would be useful. What we have currently is fairly high level. Chattiness of protocols is a big issue. Avoiding that would be useful. Transport optimizations, the one idea that I just talked about, is one example there, but we haven't really confirmed that actually provides savings. So that's an area where research would be welcome. So if anybody's interested, please engage in that research or talk to us. And then the message encoding mechanisms, that's also an area where sort of finding the actual data, that in which area or which protocol or which type of traffic this would actually help significantly. So the ask for you guys is basically that please engage in discussion either here now or on the Sustain mailing list or on the e-impact mailing list. This is the beginning of the work. Will continue for some time, so please contribute, and then the research topics, please jump on them. So I think that's it. I don't know if Suresh, you want to add anything, or you want to come up to help answer the questions, or but I'm ready to, or we're ready to discuss.
Thank you very much, Jari. Much appreciated. Indeed, there are lots of potential research questions coming out of this study. So we appreciate to have them in Sustain RG. Now, any questions to Suresh, Jari on this topic? The queue is open.
Dan York, great work. I mean, I looked at the document, lots of things. I guess my question more generally was, what's your next, like, what are you going to do with this document as far as what's your next thinking around that?
Yeah, thanks, Dan. So we put in like a set of topics that we think have sufficient maturity to actually provide guidelines. So that's kind of the cutoff point, right? Like where we say like, okay, if it's not going to be able to give concrete advice to either protocol designers or network designers, that's out. That's like one thing. So that's about the content. And administratively, if your question is like, what are you going to do with this document? The goal is to actually put it up to the IAB for adoption at some point when it's ready, when we think it's ready, when we have the things we want, and take out the things we don't want. Because like it's certainly possible we're going to throw stuff out. But the goal is to publish this on the IAB stream as an informational document.
Cool. No, I mostly asking because it's got a lot of good information inside of it. I wondered where, you don't want that being lost somewhere. It's, thank you.
Thanks. Gaetan?
Hi, thanks. I have a question regarding all the work there, I mean, and the previous presentation. there's many areas of possible improvements. How do we do to collect really the exact real numbers of what's really happening in the field in order to know which are the areas of improvement which would have the biggest impact to start with?
Yeah, that is of course an issue. So the work that we've done to date is that we try to understand that in principle this kind of a thing would have this size of an effect, that it affects everybody on the internet, or just 5 people. There's a difference there. Affects all protocols, just very small subset. So that's been our guideline so far, but it would be super helpful if we could ground some of these things into more concrete numbers. And there's certainly some amount of research around that has some data. I mean, you could just show some of the things. It's a little difficult for us to sort of put a particular number, because it's always like a context that, well, like you talked about mobile networks and so on. So, but what about other types of networks? So I think that's a bit of a challenge for us currently, but I don't know if you have ideas on where we can get information or how we should approach that, and that would be helpful.
Just to also add one more thing, I think it's important to state it. It's in the document, but just wanted to bring it up, right? Like, so a lot of these things could have different effects in different protocols or environments, right? Like, so the idea is like, this is a set of things that we know that how people can consider things. One of the examples that came up was like multicast versus unicast, right? So there's like cases where multicast is preferable and cases where unicast is preferable. So like the idea would be, what we're trying to document here is like, look at these kind of things before you do the stuff, right? So, so what becomes more relevant, or like for a given technology or like network or everything, that could change quite a bit in addition to everything Jari said, right? Like the idea would also to be consider that like savings for a given use case, like as well.
I'll just give a very simple example. I think a lot, of course, comes from the behavior that we all have and the trends that we push in the consumption. But clearly, I'll give an example for France. Almost everyone today is watching TV over streaming, over the residential internet services, which of course consumes on the data centers, the streaming, the routers, everything. But most of us actually watch in real time the live TV broadcast that you could receive over the air. I mean, consumption-wise, I mean, if everyone was switching back to terrestrial network television, I would believe it would consume less than streaming everything to everyone most of the time in unicast and not even with multicast streams.
Yes, that's a good example, but I think on the other hand, we probably want to do the math to actually calculate that your claim there is correct, because yeah, you'd have to manufacture, like, the manufacturing of TVs was a big chunk of the embedded carbon impact way back, and probably still is, and when you have like a single thing that can be used for multiple functions, that's a benefit. So I don't know. We would have to do the math.
This is why I was asking the initial question. Is we really need a characterization of what behaviors and what traffics have the most impact in terms of the cause of the impact, and how you can improve for each of those causes the network behavior to reduce the footprint and the production, of course, recycling.
Getan, like there is like a modeling section, right, where we talk a little bit about this, but we would welcome content from you if you want to send something. Thank you.
It's sounding like sort of trying to identify representative scenarios might be useful. But yeah, I realize that's hard. Jinji.
Hello, this is Jinjie Yan from ZTE. Thank you for your insightful presentation. And regarding to the transport improvement, you suggest that the sending faster and the speaking longer would benefit, but you mentioned a precondition that the nodes should have energy proportionality. And from some researches and papers I read, most of the network devices, for the most devices, that the energy efficiency and the low load is much worse than that with under the high load. So can we come to a conclusion that the sleeping longer and standing faster will still be benefit if the device without energy proportionality?
So I think that first of all, the energy proportionality situation is probably not uniform. That it's bad everywhere. There's differences between different technologies and different types of devices. So wireless generally, maybe slightly better in this proportionality sense than fiber networks. My understanding, but you do need this. Absolutely, if you want to play with sleeping nodes, then we really have to have some level of energy proportionality. I don't know where exactly the line goes. Of course, it doesn't have to be perfect. Maybe a little bit already helps. We'd have to do the numbers, but it's a condition. Unfortunately, we have to do multiple things. We need to have energy proportionality, I think, for other reasons and not just for this technique, but also for this particular technique, we absolutely do need it, I think.
Okay, thank you.
Yeah, Jukka Manner, just a comment to the previous speaker on the what to do next. I mean, there's no silver bullet. There's no one thing that solves everything. So the whole problem comes from small changes here and there that adds up. So I would urge not to try to think of one is the best thing to solve the whole problem, but what are the 100 things that need to be done?
Thanks very much. Thanks very much, Jari, Suresh. Great talk. Next, we want to get a glimpse of what research topics are coming up in this domain, and a sample from a recent workshop held as part of Dagstuhl seminar series. Here is Dirk. Thank you.
Yeah, thank you very much. So this is about a last year's Dagstuhl seminar.
You can use the button to advance.
About a last year's Dagstuhl seminar on greening networking towards the net zero internet, which I co-organized together with Alex Clem, Michael Welzel, Cedric Westphal, and Noah Silberman. If you don't know Dagstuhl, so Dagstuhl is a computer science conference center in West Germany that is sponsored by the federal state of Saarland. And so their concept is, let's lock in computer scientists for 3 days or 5 days and don't let them out of the castle until they have produced some results. And it's quite good experience. And many IETF topics have been further discussed or even coined at such Dagstuhl seminars. Initially, this talk was intended to advertise the report that came out of the seminar. The report is finished. Unfortunately, Dagstuhl hasn't published it yet because they publish these reports in volumes. So I have to tease this a little bit, and then you have to read the report when it comes out in like 1 or 2 weeks. Okay, so this seminar brought together a bunch of interesting people. So academics, not only from networking, but also like dedicated sustainability researchers. Then people from network vendors and network operators, and also application service providers. So that was, I found quite a healthy composition, and that led to many interesting discussions just beyond, the like how much can we save per bit in the network aspects. And yeah, so I just picked some topics that have been discussed. So I don't think I need to discuss this much more because I think Ali mentioned it in the beginning. So the motivation, I think, is clear, it's the same. So at the seminar, we largely discussed things around 3 dimensions. So applications, systems, and stakeholders was like one title. we looked into things such as, web applications, streaming, media streaming, and AI workloads. Then we looked more particularly into networking technology. And then another topic was like life cycle and control loop aspects, so for energy consumption management. Of course, there were like other, aspects, other dimensions, like decomposition into different parts of the network and so on. Also time horizon. So there, in this field, many things are proposed with like different time horizons. So what you can do immediately, what you maybe will be effective in 5 years or even 10 years. So we also try to sort this out in the seminar. And yeah, it has been just discussed, right? So, if we changed our way of consuming media, how much energy could we actually save? And so I think Yari gave the right answer, right? You really have to analyze this carefully and do the math. So this is from a Netflix report. So of course maybe different people, different organizations have different views on this. But according to this report, the biggest share of the energy consumption is actually in our households. So, and the display is like one of the main drivers for the main consumers of energy. And so that means if you change the transmission architecture or something, you might save a bit, but to really debate whether it's worthwhile and whether it makes a real difference. So interestingly here, the internet service provider part is only 10%. I mean, it's not negligible, but it's comparatively small number compared to the almost 90% of our home devices. And yeah, so it was also mentioned earlier in our energy proportionality. Of course, that's what people typically strive for, but then there are also many misconceptions. So here this refers to some events especially in Germany during COVID times, right, when people were sitting at home and watching video. And then I think it was maybe even the government or something who recommended that the video application provider or service providers, they would switch the resolution from 4K to just HD to save energy and to reduce the energy consumption, which turned out to have zero effect. So, but it was like deemed as an effective popular measure. But so it's an interesting lesson, right? So what beliefs are existing and what the real effects are. So it's maybe also good for this group to analyze this carefully and study the effectiveness. And so another thing. So I also worked in this in the past in mobile networks. So I think one interesting aspect about energy proportionality is, of course, you can, reduce consumption of current systems to some extent, and it's most effective if you can, scale back like larger parts. So maybe not only the radio, but maybe also the whole base station, let's say computer, or even the air condition in the cabinet. So, but if you want to do that, quite often that means you have to design systems so that they explicitly support this. So when you do, like, for example, site sharing in mobile networks, makes it much more difficult to scale back that much. Another aspect that was discussed was so-called attributional versus consequential carbon emission. So traditionally, companies, for example, they like to do attributional accounting. So I often apply it to reporting units or something. So how much carbon emission here, how much carbon emission there, which could sometimes be misleading. So in research, people try to kind of now look at more like a holistic picture, and say, for example, when you have a data center that switches to renewable energy, of course that's good for maybe the environmental reports of that data center, but it could also mean that suddenly, say, other consumption has to move to maybe less carbon neutral energy if the amount of renewable energy is fixed. And so we had some, researchers that are working on like ICT, sustainability, and so on, and these are the topics that they are discussing. And yeah, I think there's also an interesting debate to be had, right? So how do you see the adaptability of, for example, ICT systems in the future? So if you, for example, think, okay, you have nuclear power, you have like stable, cheap energy production, then you might say, okay, it doesn't really matter, you just want to kind of keep your systems running. There's also current research to what's called sector coupling, right? To put energy consumption, big data centers closer to energy production, which may have more dynamic energy production. And the question is, how adaptive, how scalable are these systems? If you could do this, you could save a lot, but of course, then also the, say, behavior, user experience, and so on may be affected to some extent. And so another topic that so these ICT people discuss is flexibility requirements versus flexibility potentials. So it's great if you can kind of optimize your own energy consumption, maybe based on dynamic pricing and so on, that your bill is just lower. However, this may then create, say, less desirable peaks in the demand at times where maybe it's actually not so convenient for the overall grid or something. And so if you believe in this adaptability, then it's more productive to think about flexibility potentials. So design adaptive system that can better respond to cost indications and changing energy budgets. And so this is, again, these like co-located data center and energy sources. So just a very quick run through, but so first takeaways that we wrote down was like, yeah, we need to understand, like, so what does it actually mean when we talk of greening networking versus sustainability? And so most people in the sentiment thought it's very useful to, take a broader perspective and not just networking by itself. And I think this is much in line with what the group is planning to do. And so our suggested perspective is like more network systems. So the video streaming plus the network, the AI and the network, and so on. And yeah, then interaction of these network systems with energy sources, so the grid, the local renewable energy, studying these flexibility potentials. So that calls for cross-disciplinary approaches. And yeah, then it's probably also fair to say that technology alone will probably not solve the problem, not save us. So there are all kinds of other socioeconomic factors and constraints. And so we all know, like the big investments into AI and also plans to build out new energy production just for that. So currently, I mean, if there's lots of profit to be made, you can be sure the energy will be produced. And so the question is, how do we balance these, short-term privatized costs or privatized profits with the long-term societal debt that they may incur? And yeah, again, so sadly the report is not available yet, but I will post it on the mailing list as soon as it is. For now, there's a press release, Darkstuhl, and some write-up on my webpage. You can't read this, but the report will contain an assessment of different, proposed topics or research topics, potential measures that could be of interest, and it's gonna, yeah, we are kind of classifying this like in terms of what impact do we see, like high, low, medium, what time frame do we expect, And also, what are the grid dynamics? So how would these technologies or these measures then interact with the energy grid? Okay, that's it for me. So there's the link to some write-up and the press release. Thank you very much.
Thanks very much, Dirk. Any questions to Dirk? The queue is open. Dan, please.
Dan York. So this is really interesting. So I'm looking forward to the report. I'm just curious. I was delighted to see the emphasis around power and infrastructure. There's some other work happening outside of the IETF and some other areas around internet resilience and looking at the places there. And in this, the whole power aspect is obviously one of those bigger aspects that's been identified. I'm just curious, in the research that was there a section around energy, power resilience kind of things, or?
Yeah, so we had people who explicitly work on the sector coupling topics. So there are projects in Germany, so where they're building like prototypes of these like little data centers close to wind turbines and so on. So if you're to that, yeah, that would be also in the report. And so I can also give you the name of the colleague who's working on that.
Yeah, cool. I look forward. So you said in a couple of weeks here it'll be published or something?
Yeah, 2 weeks, I assume.
Oh, perfect. Great. I'll feed that to some other stuff doing.
Thank you, Dan.
Any other? Thank you so much, Dirk. Thanks. Now we have an open mic session where we want to encourage your participation. We are some 60 plus colleagues in MeetEcho and here. So around the topics, around the questions, what you have seen, of course, but also what you think you want this group to work on, or you are working on, you want to interact with, what are your favorite research topics? So let's use the queue again. If you want to bring up a topic, please get in the queue and we'll discuss. Yeah. Okay, but yeah, then
somebody else come up here, to the mic. Ali won't bite. Dan York. So I would just say I really liked the framing of this, the piece around that. Since you asked those questions, maybe you should display those 3 questions you have.
Sure.
Get that up there to inspire some others to come to the mic. I will say that I'm personally interested in that one small slide you had that was later in there around the adaptation aspect of it, and how do we ensure that the internet continues to keep working in the face of climate change. So I'll just throw out, if anybody's working on that, I'd be interested to talk. I don't realistically know how many cycles I have to help with that too much, but I would be glad to participate if people are interested in doing that kind of thing.
Thanks very much, Dan. Indeed, climate change adaptation is a important topic, of course, for operators and of course for vendors of internet equipment, because they have to get ready for a new reality. And we are seeing these kinds of requirements starting to appear in requests for codes and information. And it's about the robustness of equipment, but also the resilience of networks going forward. It's an essential topic. Of course, it's distinct from the footprint, handprint aspects, but it is nevertheless one of the key areas. So if you have interest, please, indeed. Thanks, Dan. Marisol, please.
Hello, Marisol Francisco. I don't know if you can hear me. It's fine?
Yes, we hear you well,
okay,
Marisol.
Good. Last time I was joining from remote, I couldn't get my audio to work. But thank you very much for everything that has been shared. And thank you for the creation of the working group, right? I think is really valuable, and it is, I think, something in between, as you mentioned before, the IETF Green Working Group, and how it could be more impactful outside as well. But I have a request, and this thought has been shared already on this forum and the impact. But there is something that from the networking side, we could see evidence, we could see use cases, but still, I think, and I would like to ask how this group could help to bring those consultants, those people that are looking into the business drivers for the companies, the organizations, because I believe there is still this connection between what the company could put as a net zero objective for goals and what we are doing from the ICT perspective, on all these intentions to optimize energy and share best practices. Then I guess from the research, it can be done some showcases, right, to drive more sustainable operations, to drive more equal objectives, talking about carbon, talking about energy. We are looking at the same problem, but from different perspective, but to align these two perspective, or people driving these activities, how this group could also help for bringing the common vision, right?
Mm-hmm.
It's more an open thought. Thank you.
Thanks very much, Marisol. Indeed, this is a key aspect, that we connect the research with the operational impact. As Marisol said, we have colleagues who see the impact in the field. They are working in IETF working groups and independently, perhaps. Then we have the researchers who are developing distinct technology enabler solutions or protocols. How do we connect the two and demonstrate that the innovations have real impact on sustainability of the network operations, of internet operations? We hope to indeed provide the community opportunity to make that bridge. Thanks, Marisol. Next is Huda.
Ali, can I just hop in for a moment? This is
Sure,
Eve.
Eve.
I wanted to also just point out that one of the talks that we are wanting to queue up for the next session, if the scheduling can work out this time, is to hear back from the Sustainable Subsea Networking community, because it had a very interesting strategy, which I think we should echo here, which is to try to understand who the stakeholders are when we say networking that's within this sort of purview of the IETF and IRTF, and to bring diverse stakeholders into the conversation so that you get these perspectives and assessments, and those different stakeholders who have different incentives. There's been on the chat quite a bit about, how do you incentivize the right thing? All of those people to come together to form a strategy, or at least that was something that intrigued us about the subsea community, subsea cable community. So anyway, so that's just to be a little teaser for, I'm hoping we'll hear more about how that came to pass and how we might echo it here.
Thanks, Eve. Thanks for bringing that up. Appreciate it. Huda, now please.
Thank you so much. So I encourage to focus more on the topic of AI.
Huda, can you approach the mic? We don't hear you well.
Okay, thank you so much. I encourage the topic of to focus more on the topic of the use of AI for sustainability.
Mm-hmm. In what aspect? What do you see as the problem
use,
there?
For example, proactive detection of any increase of amount of energy consumption of any integrated if we integrate a new product or something of our network.
Thanks, Huda. Indeed, AI is a recurring topic, of course, in everything these days, but also in terms of optimization when we talk about the efficiency aspect of sustainability, AI comes into the picture for correlation and optimization in every domain. Then, of course, there is the issue of AI's own footprint. That also needs to be characterized. And although independent, at system level, we have to indeed look at the overall balance. What benefit did we get by deploying AI on a certain solution or a problem, and also accounting for its own footprint. So indeed, we include AI as a general topic, but we also want to encourage focusing on, let's say, core networking problems initially. Thanks, Hoda. Next, Vaibhav.
Vaibhav Bajpayee, Hasso-Plattner Institute in Germany. So the IETF has had a long tradition of eating its own dog food.
Sorry, I didn't hear you. Can you approach
IETF has had a long tradition of eating its own dog food. So particularly with V6 Ops, they have been running this V6 only network to promote people to use V6, to try to understand how V6 is actually being used in practice. The Sustain working group can also do something similar, right? So we can eat our own dog food. For one I can think of is we could try considering turning off air conditioning in our rooms, at least in the rooms in which we are meeting. So if I bring anybody from outside the IETF into this room and they see all of us talking about sustainability, sitting in air-conditioned rooms,
yes,
they will think we are completely out of our mind, right? And we can go even further. We can think about an online first approach to meeting in sustainability research group. A couple of years ago, we ran a dark stool seminar on reducing the climate footprint of internet research. And many of the folks at the IETF were also present there. And we were equally productive in actually doing this. The worst outcome of this working group after several years of working together would be the energy consumption of all the participants combined was more than the outcome that came out of this research group. Thing to think about.
Yes, thank you very much. So I understand your intervention is about the operation of this research group, and you are very right. Air conditioning has been a hot topic in IETF for the longest time, I believe, and we are on the same page. I think there are things beyond the control of this group, but more generally, there was a recent activity for the footprint of IETF in general and making IETF net zero. So this is a topic that IETF LLC took over, I think, just the operation of the IETF organization itself. And I think air travel, meeting in person, all of these aspects were handled there. And we had commented on this because there was a consultancy involved, and as was mentioned earlier, offsetting was provided as a solution, which is in itself not a solution, of course. So these are all aspects. Of course, in return, I would ask you the question how to characterize the output and impact of this working group as compared to its footprint. That's not easy. If we held only online meetings, what would be the result? Even in ITU, there are methodology standards how to compare the footprint of online versus in-person events, because things change. When you make something online, maybe 5 or 10 times more people participate as compared to only in person. So it is hard to gauge the impact per person, what the footprint of that event is or isn't. But we will be mindful exactly of what you're saying. That's why we included online events in. Sorry, thanks. Dirk, next. Sure.
Yeah, just on this. So I think this topic of turning the AC off is a good example of attributional versus consequential measures. If you have to cool down the room after the meeting, not sure how much you actually save. Second, so this topic of saving energy by not traveling, I think that's an explicit goal in your charter, if I remember it correctly. So a non-topic in your charter.
I mean, I would also add that clearly it is important for the IETF to consider the environmental impact of its operations and the IRTF to do that. I think that is a separable problem to the task of this research group. So yes, that is a debate that should happen, but I think it's a broader debate than for this particular group.
Indeed. Thanks very much, Dirk, Colin. Jim, please.
Jim Reed.
Last.
Jim Reed. Yeah, I just agree with the comments that have just been made by Colin and with Dirk. It's all very well talking about the carbon footprint of these meetings and air conditioning at the venues and flights and all the rest of it. But that's not really, I think, what this research group should be about. And quite frankly, the carbon impact of an IETF meeting or the energy consumption of an IETF meeting is kind of lost in the noise. What we should be focusing here on is the energy impact of the protocols that the IETF comes out with. I think that's the sort of thing that this research group should be looking at, rather than, can we save a few grams of carbon dioxide by switching the air conditioning off?
Thank you. Thank you, Jim. That's clearly the case. If you look at our charter, indeed, we are not focusing on the operational aspects of IETF or IRTF. We are focusing on the network. So with this, we have run out of time, but thanks so much. I hope this first session has given you an impression of what lies ahead. There are certainly questions, as we have seen from different discussions, like nodes, are they energy proportional? Networks, are they energy proportional? Even within this single meeting, we had a question about that, and we again need data and certainty how to formulate these questions. And also flexibility came as a request, and also our architecture presentation showed that there is a crossing from implementation considerations towards research and back. So what we do in this group will translate into recommendations, hopefully, towards protocol designers in the future. So I emphasize again, we are really looking forward to consolidating the research questions. We are looking for owners who will work on those questions, and we want to make this relevant for the IETF. Thank you so much for your attendance. Our email list will be active. I want to thank my co-chairs, Yves and Michael, who were participating remotely, and everything that has happened on the chat as well. Thank you so much.
One last
Yves?
thing, which is before Colin leaves his position as the chair of the IRTF, I wanted to thank him for his tremendous guidance in the kickoff of this group, as well as Dirk, who's the incoming chair, and we look forward to working with you. So thank you for that as well. And thank you everyone, regardless of where you're participating from.
Thank you, Yves. Thank you for to the chairs. I look forward to working with this group. I think it's going to be a great group.
Thanks very much, Colin. Again, looking forward. Cheers. Meeting is closed.